stories that might be fun. Moodle is the online course management system we used to use before we switched to Canvas, and apparently it's had a flaw for 6 years with nobody noticing. So they showed conditions under which it had to do with, I think, like an equation editor. Some way to insert content that would then be processed, and there was a way to inject script in there and steal cookies. So it sounds pretty common. Doesn't matter to us anymore in our college, but a lot of other people, I imagine, still use Moodle. Apparently, we're in for a really bad fire season, which would certainly make sense. I've been hearing all this news about bad weather elsewhere and figuring that would be our turn. And this is a measure of the amount of moisture content in the foliage, and it is lower than it has ever been. So the trees and shrubbery are drier than they've ever been at this time in the year, and so because we haven't had enough rain. And they're already talking about water conservation, but of course the other immediate consequence of that is fire, because it's much more likely to catch fire when it's dry. This has been getting a lot of press, the name rec vulnerability, which I haven't seen much details, like enough to actually do it, but this is another DNS vulnerability. There have been quite a few of them. And apparently there is some kind of DNS response compression feature, which I've never used, didn't know it existed. Yes, but that's right. I see, time to get different masks for smokes. Well, it's pretty much the same mask. I've got some N95s. That's what you're supposed to get. I got some KN95s that are almost as good. Yep, you got to have them for smoke anyway. Anyway, so these guys have found a lot of vulnerabilities, and now they have found a DNS vulnerability that has something to do with memory pointers and message compression. So that does sound pretty dangerous. I didn't know there was a way to compress a DNS message, but apparently if you do that, quite a few operating systems do not understand it correctly. So there's been the 14 times since the year 2000 this has caused vulnerabilities, and this affects FreeBSD, NucleusNet, a bunch of other packages. So 100 million devices are running vulnerable stacks, they say. And of course, the worst is always going to be the IoT devices, the little portable devices that are hard to update. So anyway, I'm sure we'll be hearing a lot more about this. And when there's a proof of concept, it might make a good project for the hacking class or the DNS security class. Japan has this nuclear plant that got wiped out years ago, and they have had no luck at all containing the radioactive waste. They've tried a lot of tricks and it keeps leaking out. So they've now decided to admit they can't contain it, and they're going to, in 2 years, they're going to start dripping it into the ocean, and they're going to keep doing that over like 20 years. Hopefully keeping the amount of radiation down to what they regard as an acceptable level. A lot of people are upset about that, but they probably have no real other choice. Yes, undoubtedly. Undoubtedly, if you've been eating seafood, if you ran it through a detector, I think they showed even when it happened, it was in the air, it was in the water. Yes, you'd probably been eating a tiny amount of radioactive stuff in the seafood. Of course, there's some radiation in the background anyway. So there's probably a pretty good argument that there is a safe level and they're keeping it down to the safe level, but certainly it's not a very nice thing. That's why I'm very pleased to see the progress towards fusion. When we move from radioactive fission to radioactive fusion plants do not produce any radioactive waste, and they make a lot more energy. So, and they say the first one of those is going to be online within like 5 or 10 years. So that would be the real green energy if we could be using nuclear fusion. And it's a lot closer than I thought it would be. So the FCC has had the ability for years to stop robocalls. Robocalls, so have all the phone companies. They know who's putting out the robocalls, which is pretty obvious because who else is making like 1 million phone calls a day? Oh yeah, fusion is great. Fusion, you just start with water. You combine the water, and the only radioactive side effect is radioactive waste product is tritium. And tritium is not very dangerous, and it decays in 7 years. So it's easy to get rid of. It's great. The sun uses it. The only problem is it's very difficult to make a fusion plant. You have to recreate conditions like the center of the sun, and that's pretty expensive. But they've apparently reached the point where they can make net energy out of it, so that would be great. Anyway, so the robocalls, if you think about the phone companies, they know who is it that's making 1 million calls a day. There aren't too many customers like that. So they can tell who's doing the robocalls, and they don't bother to stop them because they're making money off them. So the FCC is finally going to do something about it. Under Trump, it was Ajit Pai, and he mostly didn't want to do anything about anything. He was the sort of typical Republican fox guarding the henhouse, where they just get somebody who is supposed to regulate an industry, but they're totally in bed with the industry, and their idea of regulation is to just let the industry get away with anything. That's what they call the pro-business attitude. So anyway, if you get a software-defined radio, these things are only like 20 or 30 bucks. I've got a couple. And I've been using them to pick up signals from satellites, but you can also pick up signals from your devices. And now they say you can pick up the signal from your smart meters. And you can reverse engineer it and figure out how they work, and you can probably spoof them and such. So it's interesting to see. I haven't been through this yet, but it might be a good project. We do have a space workshop coming up using software-defined radios to do things, and might be in there. We'll see. And here's a good article from a good video from a historian explaining where the filibuster came from. The filibuster was a mistake caused by Aaron Barr. It was never part of the U.S. government. It's not in the Constitution. It never has done anything good. The only thing it was used for was to further slavery and block civil rights legislation back when the Democrats were on the other side of that issue. And the only thing it's doing now is paralyzing our government entirely. So in a logical world, you'd get rid of the filibuster, but it remains to be seen whether they can find the votes to do that. Of course, Democrats used it in big important cases, absolutely. They used it to block civil liberties and slave abolition around the time of the first Civil War. And the time right now in America greatly resembles the time around the first Civil War, when you have two very, very angry extreme camps that totally hate the other. And we're very much back to that again, and over exactly the same issue, civil rights. We never really resolved the Civil War, and we got basically the Republicans have basically jumped in with the Confederates, and the Democrats are on the other side. So it's sort of the North versus the South again. J&J COVID vaccine has a 1 in a million chance apparently of causing a dangerous blood clot that might kill you, just like AstraZeneca. So they've stopped using it in several states in America, and the FDA has recommended pausing it for a while. And while they try to investigate it, they also investigate it with AstraZeneca. And I think what they decided in Europe is it's okay to use it, but they use it only for certain ages of people. And the main point is to find a way to watch for this side effect and deal with it. But it is pretty nasty. It comes on like 2 weeks after you take it. You get a headache and then you die. So that's rude. But the chance is very small. 6 cases of clotting in over 7 million people that took it. So you have a 1 in a million chance of the vaccine killing you. And that is, of course, much less chance than COVID killing you. From a mathematical risk analysis, you'd be much better to take it, but it would be nice to even moderate that. I mean, in America now, they make you sit around for 15 minutes after taking it to see if you have an allergic reaction, and that's also very rare. But, people are more comfortable when you have a mitigation on all the risks. So this one here, the Australian is going to have a blockchain. They're trying to do this thing called income compliance. And it's going to watch your income to make sure that you're not getting too much or something like that. I'm not sure. But it's also going to be a blockchain, which is almost always an indication of a totally fake program, because the blockchain doesn't do anything that a database doesn't. Anyway, the anti-vaxxers are totally going to have a field day with that. And all the people that are hesitant are now going to have a reason to be hesitant. I've got several friends that refuse to take the vaccine, and they keep changing their reason, but they basically don't want to do it. And, this will be another excuse. So a lot of Americans are obviously not going to take the vaccine. That's my feeling. And therefore, you can forget herd immunity, you can forget vaccine passports. I think we're only going to get about 3/4 of people that take it. The others are just not going to take it, and that's where it's going to sit, I think. But anyway, we will see. So here we are today with Chapter 7, analyzing malicious Windows programs, and then I'll demonstrate the WinDebug projects, which I just went through and updated. There were a few little mistakes in them that I fixed. Yes, as far as I can tell, the blockchain is only good for a scam. The blockchain does nothing that a central database doesn't do. It's a central database plus this bizarre, highly expensive reproduction feature with the miners, which is nothing more than an extremely expensive way to implement mirroring, and does not really solve any problem that exists. But it's a fashionable way to confuse people, so they'll give you their money. And it's getting very, very popular, but there are various things that get popular and still are based on nothing, like, 3/4 of Republicans believe that the elections are all rigged. By Hugo Chavez hacked the voting machines or something, and it's totally not true. And I think similarly, a lot of people believe these blockchains are somehow going to save the world based on no evidence at all. It's totally not true. But it's going on for quite a while. Ethereum is supposedly going to switch to proof of stake, and we will see what happens. Yes. Oh, and there are ways to make blockchains more efficient. There are ways to address the defects with blockchain, but the one defect I've never seen fixed is that there is actually no reason to use it. There's no actual problem. Oh, feel free to ask. I mean, a lot of people are taking blockchains very seriously. Tons of money are going into them, all the big banks and everything. So, if enough people do something, it becomes important even if it's totally wrong, like the big lie. So it is an important trend. Yes, but when they try to explain, people act like they're magical, but if they try to explain to you what exactly I'm sure they say the blockchain will somehow get money to all the poor people in other countries that don't have any bank. And how are they going to do that exactly? Anyway, being a public ledger versus right. Well, if a private blockchain is nothing more than just a single database that we already have, and the public ledger is the unique feature of blockchain, but there has no virtue that anybody knows. Anyway, good. These are very good points, and we can talk more about it later. And I'm teaching cryptography again next semester, apparently, and we will be building blockchains and using them, and you can see them go. But the one answer I'm not able to give you is why you would bother. We will see some so-called use cases, and the technology designed to use them, and you learn how to set it up. So you could get a job programming it, and that would be a good job. I certainly don't recommend investing in it, though, because I think it actually has no use. But of course, if you're just a programmer, that's not your problem. As long as the check clears, they pay you to program it, and it's somebody else's problem whether it actually is any use. And there's a whole lot of cryptography and mathematics in it, and some of that may have peripheral advantages. Anyway, so with the Windows API, we've already talked a bit about this in the extra credit stuff about the Flare VM, but here's the stuff from your book, which is good to go through. So the API is how you call Microsoft libraries. If you're going to use Windows, everything you do has to go through the Microsoft libraries because they're the only ones that have direct access to the hardware. So here's the basic concepts we're going to talk about. So there's types. It was all written in C or C# or C++ versions of C. And so you have DWord for 32-bit integers and Word for 16-bit integers. And this, in its Hungarian notation, you put a prefix like DW for double DWord size, just to refer to the size of things. And so you'll have word, double word, handle is a reference to an object, and a pointer points to an object in memory. Very much like a handle, but there's a subtle difference that doesn't really matter much to us. So a handle is something you open. And if you've ever written C, if you want to open a file to print the disk, you do F equals open, comma, something or other, and you get a handle to the file. It creates the file, and now you have a handle, and now when you write to that handle. That's what you do. And this is true of any object you create, to a process, a menu, a file, a window. You get a handle, and then you refer to that handle later when you call another API function. If I say, put this text in a window, I have to say which window, and I have to use the handle to the window to tell the operating system which window I'm talking about. So you create window here, and when it's done creating, it returns a handle to a window, and if you want to do anything later, you use that handle. So you can create files, read and write files, map view of file. These are things that load file directly into RAM, not that common for legitimate programs, but a way to load data into RAM to execute it in non-standard ways, which is what loader malware does. To try to load something in a non-standard way to try to get past antivirus. And you have special files. If you have a server on a Windows system, you can use / and the server's name or IP address, and then the sharer's name, and you will be connecting over the network to a shared volume on some other server. Or you can put a question mark in the middle, which will let you have longer file names. There are special ones. / is the root of the whole tree. And // gives you direct disk I/O. If you've done this in Linux, this is important. Direct disk I/O connects to the physical disk, not the logical drive like C, D, and E, which are partitions on a disk, and there is some other data on the disk outside those letters you can recur to by getting to the actual physical disk. So if you want to destroy the disk, you write directly to the physical disk, and then you wipe out all the control structures so it can even find the partitions and such. And that's also what you do if you wanted to make a forensic image of a disk, and so on. It's another way to refer to the contents of a disk or other devices. There are alternate data streams, which is one of those rare things. This is a Microsoft feature for compatibility with Apple. So Apple was big in music when Microsoft was not. And if you buy commercial music, then you want to have not only the music, but you want to have the cover art and the album notes and the credits and stuff. So you really have multiple pieces of data attached to the same file name. And the way they did it was with this thing called alternate data streams. So I can create a file called foo by putting a 1 in it. And then I can do a directory of foo, and it will just show me that foo is 4 bytes big. But I can then echo more data into foo::bar.txt. You take the file and you pretend it's a drive letter and create another file inside the file. And now, even though it still thinks it's 4 bytes, the total amount of free bytes on my drive shrunk the last time I did it, but this probably wasn't enough to make it happen. Anyway, the point is you do have bar.txt, so that you can have a second stream connected to the same file name. And maybe 10 years ago, this was not commonly known, and antivirus would miss data put in there. Now everybody pretty much knows about it. But anyway, that's alternate data streams. And the Windows Registry came out with Windows 95. If you have a Linux program like Apache, Apache has a bunch of these configuration files, like apache.cfg and unfortunately a whole bunch of others. And that's where you put all the settings, like your IP address and your domain name and your security features and such. And if you install it on a different operating system, you just put a text file along with the executable files, and that's what controls it. And that's the way MS-DOS did it. But when Microsoft moved to Windows, they said, let's not have these little text files all over the place for all the settings, for all the programs and user interface elements. That's a mess. We're going to make this binary object called the registry that has all the customization settings for all the Windows components and all the installed software in one object. So it's a binary object stored in about 8 files all over the place, combined and viewed through this thing called regedit. That is the list of all your personal settings and all the settings for all the software that's installed. And malware you can do almost anything by modifying the registry. And malware can make itself automatically launch by writing to registry keys that specify which programs to automatically launch. The registry looks like a tree-structured group of folders, but these things are not folders. They're more like database entries. That's why if you have one of these things, even if there's no data in there, it always has to have at least one item called default with no set value. Then anyway, these are the root keys, they call them. Classes root, current user, local machine, users, and current config. And this is really, really messed up. They don't map one-to-one to files on the disk, and some of them are actually referring to subsets of the others. This is the way Microsoft always did everything. Microsoft software is not written by mathematicians like Unix. It seems to be written by committees of business people, so there's always like 5 similar ways to do the same thing and no real logic. It's like a snarled up piece of yarn. But anyway, that's the way it is. So we use regedit to see this thing, and those are the root keys with what they are. And anyway, so some of them are particularly important to us, and like the run key. There's a few of these, and the run keys are things that automatically run under certain conditions. So if you go into the run key, which is this long path, and you get used to browsing through the registry here, then you find things like Adobe and a Dropbox helper and LogMeIn. These are things that will automatically launch when you reboot the machine. So there's just paths to them. So you can just add a path to your malware here, and then it'll automatically launch. A common place to do that. So if you want to find all the things that automatically launch on your Windows machine, this is actually very difficult. Microsoft does not provide any tool built into Windows to do that for you. But sysinternals, which Microsoft bought, gave you this auto runs tool, which is pretty good. This tries to find all the things that are automatically going to run. It can't find them all, because there are many, many, many ways to automatically run software on Windows, but it finds a lot of them. You run auto runs, it will mostly find all the things you're automatically launching on your machine. And then you can decide if you want all these things happening and possibly notice if some of them look suspicious. So here's API calls to manipulate the registry. This opens a key, this sets a value to the registry, this reads the registry. And when you read documentation about an API call, it'll often omit the trailing character, which would be either W for Microsoft's strange old-fashioned 16-bit Unicode, or A for ASCII. And EX means an extended function, which means this function was in an earlier version of Windows, and this is the new extended version of it. You can even have EXEX. So that's a good thing to know. And there's some conventions here like the EXEX and the W and such. You'll find those suffixes missing from documentation, but you have to include them when you really call the function on your version of Windows. So here's some assembly code that will modify the registry. So here it calls reg open key, and up here it defined this string, software Microsoft Windows current version run. So it's opening the run key, and then it's going to put a value in the run key. So this is a piece of something you'd find in a malware to make it automatically launch. And so up here it got, it opened the key, then it got determined somehow the path to it, and that's what it wrote in here. You can also have Reg Files. I used to make these all the time when I was doing Windows tech support. If you want to set one of these keys or delete a key or something, you never want to give users instructions to mess with the registry, because the registry is always live. If you change anything here, it takes immediate effect, and you can easily destroy your machine so it can't even boot up by changing the registry. So you don't send amateurs into here. So if you need to make a registry adjustment on a bunch of machines, one simple way to do it is go to one machine, make the adjustment, and then save that branch. So I could save like just the run branch. And then I just save it in here as a reg file. It's just a plain text file that just specifies what keys to be made, and then people can just double click and run this file, and it will make those registry changes, and you don't have amateurs wandering through regedit destroying their machine. Anyway, so that's the first bit. Let's take a look at some Kahoots. Yeah, there's a few ways to export registry changes, but the reg files is a simple way. I'll wait a bit. Still got people coming in. All right, I guess that's it. All right, a pointer to an object. Okay, actually I think it's technically not a C pointer, but it's something similar. So, but anyway, that's the best answer on the list. All right, handle. All right, the second stream of data in a file. The alternate data streams. Good. All right, how about a root key? Yeah, this is one of them, HKey current user. The settings for the currently logged on user. And which one is from sysinternals? Yep, auto runs. By the way, speaking of the registry, this is how McKinnon, the UFO hacker from Britain, hacked into the NSA because they had a Windows XP machine running as administrator with remote registry turned on. So you could change registry settings over the internet, and you could do anything to the machine by running registry settings. So the Chinese found it and the Russians found it, and they all used it to steal data from inside the NSA for years until they got caught. And the guy from Britain used it to hunt through the NSA's servers to try to find proof of UFOs. That was what he did. And he's still in Britain, I think. He's been fighting extradition to America for like 15 years, saying if he comes over here, we'll execute him or throw him in Guantanamo Bay or something. But he didn't actually want to steal secrets. He was convinced there were UFOs. And he eventually found like some blurry pictures of something like they always do and decided that he'd found his UFOs. But then he got caught. Anyway, all right, so I know who that is. I know who that is. And, all right, good. Anyway, he was convinced like Area 51, he wanted to find aliens or ships or something, and he was convinced that the government was hiding that from us. A fairly common belief. All right, anyway, so you got networking APIs. Now, the original days, back in the days of DOS and even merely Windows 95, Microsoft thought the internet was of no real importance. And the only network they thought mattered was local network, so you could get to your shared printer in the same room. And they had their own proprietary way of doing that, or everybody had their own. Apple Talk and Microsoft had their NetBEUI stuff. But anyway, then the internet came out. The internet was a Unix production, and it was invented at Berkeley. And they made these Berkeley-compatible sockets, which are the basis of all TCP/IP and how the internet worked, which was not in the early versions of Windows very much at all. And we're not in MS-DOS. It was added later. Anyway, so these are the WinSock libraries to make Berkeley-compatible sockets, and they're in WS232. And these are just clones of the Unix networking library. And here's what they are. Socket creates a socket, which is an object you can use to refer to these other things. Then you can bind it to a port. You can listen for data coming in and then accept data. Then you can connect to data on another server, and you can send and receive data. And if you take my Violent Python workshop, I think we still have that, we use the raw sockets. These are what's called raw sockets. Very rarely used because it's a whole lot of bother. You have to do a manual handshake and all that jazz. But this is what's actually going on anytime you do any connection over the internet, or even over local area networks these days, now that everybody uses TCP/IP for everything. So the server will create a socket, then bind to a port, then listen and accept data. The client side will create a socket, then connect to a server, and then send and receive. Those are what you'll see. So if you look in, say, your assembly code, it always has to call this WSA startup to get it going. And then it creates a socket, it binds, and it listens. So this is the server side, binding on some port, listening for data, and then accepting some data. And if you're writing shell code, you probably would skip error handling, but if you're writing any kind of legitimate code, you have to do error handling, and you have a bunch of this get last error stuff everywhere, so it can gracefully recover from errors. So normal programmers would never use that because it's very painful. They'd use the WinInet API that does high-level things like connect to a server and download a file right there. That's what you want, with taking things like a URL. It doesn't have to have a numerical IP address and all that jazz. So normal people use WinInet, the high-level API that lets you do the things you probably want to do, like connect to a website and such. So if you have, all right, jump and call, transfer execution to other parts of code, but you can also load libraries, launch processes, launch new threads, communicate with other processes through mutexes, which are handles in the file system that can be seen by other programs. And you can use these COM objects, and you can trigger exceptions and connect to services. There's many ways on a Windows machine to ask some other part of the software to do something for you. So DILs we talked about a lot. These are things that load dynamically when you're running your program, so they do not bother to load a second copy of the library if some other program has already loaded one. You could use static linking, where you have your own copy of the library, and every time you launch the program, it loads its own library, but that's very rarely used because it makes your program bigger and slower and consume more memory. So this makes your code smaller, and it makes programs load faster, but it's unsanitary. Multiple programs are using the same library, and if somebody has hacked into the library, they affect them all, and so on. But it's intended to make code reuse easy. You can write a DIL and sell it, and then people can buy your DIL and add it to their program, and you get to buy your code, you get to sell your code, and they don't have to write it. So you can put malicious code in the DIL, like we did. We made a malicious DIL with Metasploit. Or you can use the existing Windows DILs in malicious ways to do things like keylogging. And you can use third-party DILs. This is something some people do. They don't feel like attacking the Windows DILs because perhaps they're too updated and protected, so they find some other software that almost everybody has, like Firefox, and use that DIL. For a long time, they would use Flash because Flash was really vulnerable. Now almost nobody has Flash anymore. So the DIL is just like an exe. There's just a flag in the header of the portable executable format that says this is a library instead of an exe. So it's not intended to be launched all by itself. It's intended to be loaded by a program that wants to use the library function. So it has a lot of exports and probably fewer imports. And every time it's loaded, it runs DIL main, which prepares it for use. All right. Every program is a process. Every process has its own memory and its own internal handles and its own threads. And threads are what gets CPU time. So older malware launches an independent process. If you take the hacking courses 123 and 124, you'll learn how to use Metasploit. And if you use Metasploit and get a shell on a box, the first thing you do is migrate to another process. So you will attach yourself to something like the Explorer that draws the desktop, or WinLogon that stays until they log off, something like that. That's how you stay up. So that if you trick them into opening some box like a PDF or something, and it looks funny, so then they close the reader, and then you would lose control of the machine if you hadn't migrated to some other process that was going to stay there. So you add your code into a running process. So if you go into Task Manager, you'll see all the processes. There's a lot of processes, like 50 processes in this machine, which is probably a Vista. These days it seems to be more like 90. There's always more and more and more processes running. So, all right, each process has its own file system, its own memory, a certain amount of CPU it gets. And so if you have two processes, they might think they're running at the same memory address, and they might think they're writing to the same memory address, but they're not. They're running in virtual address spaces and really mapping, of course, to different memories. So they're isolated from each other. All right, so you can create a process inside a program, and then you just tell it what you're going to use for input and output and error streams and other information about it, and now you can start a process, and you can connect it to a network socket, and then you've got a remote shell where you have a process which is listening for data from the network. So here's some code to create a shell. You're going to load the socket handle up here, and then get process information and startup information. Here's your error, output, and input handles. You get all this junk ready, and then you call, I think on the next slide, then you call create process. After you've got all those parameters lined up on the stack with all these push commands, you call create process. All right, that's how you use the standard Windows API to create a listening shell. So every process contains threads, and the threads are what actually gets CPU time. Microsoft strobes through the threads. So each thread gets some CPU cycles, and if one thread is not able to move forward because it's waiting for something, then the other threads can keep moving forward. All right, so the thread has a context, and when you switch to another thread, that's called a context switch. All right, and so it stores the old data in something called the thread context, so when it comes back, it can restore that and pick up where it left off. So you use create thread to create a thread, and then you can use, so you could load a malicious DIL into a process with 2 threads, and then you'd have be able to communicate with a running app for something like a keylogger or some other form of malware. Mutex, as I mentioned, mutexes are objects you create that appear in, you'll see them in Process Explorer. They're just handles that sit in memory, and the point is other processes can see they're there. And this is how you coordinate activity between processes. So you can say, I'm using this resource that we're all sharing, so nobody else can use it till I'm done. And you could put up a mutex announcing that, and other programs would look at the mutex to detect that you're still using it. It's commonly used by malware to mark boxes when they're infected, so when you run the malware again, which often happens, of course, then it will notice this box is already infected, I don't need to try infecting it again. Therefore, it's a handy indicator of compromise. So you can wait for a single object. This gives a thread access to it, and everyone else has to wait. You can release it. You can create and open a mutex. These are the API calls you use to manipulate mutexes. So here's the OpenMutex here, which will check to see, you're going to try to create mutex here. So it's going to open mutex, and then it's going to test something. And if it doesn't already exist, it'll create the mutex here with this name, HGL345. So this is the test. If the box is already infected, this mutex will be there. Otherwise, it'll make it. All right, let's try another Kahoot. We're done with this one. Hey, all right. Give it a few more seconds to see if any more are coming. All right. All right. Where do you find bind and accept? That's WS2, the WinSock library. I see a question. If a developer uses APIs to access DILs, yeah, it is an engineer's job to make access to DIL limited. I've never heard of that. I've never heard of a DIL having limited access. I'm not sure Windows has any easy way to do that at all. As far as I know, libraries are just intended to be available to everything on the machine. It's a very interesting question, but I've never heard of a DIL not being available to every application. In Android, you sign apps, and you can make other apps with signature permission, so only other apps from the same developer can see them and share the features, but I'm not aware of a similar thing in Windows. It would seem like a good idea. I guess you could implement it yourself. You could make every app function require like a cryptographic key that you put in your app, but I don't think there's any internal Windows feature to do that. There is something called software restriction policies in a group policy environment, but I don't think it gets down to that granular level. It's a very good question, and it might be an interesting security feature to add to things. Anyway, it's ws232.dil. All right, where do you find Internet read file? Okay, WinInet, that's good. All right, what type of file is different from an exe by one flag value? Okay, that's DILs. And what's the global object used to coordinate processes? Mutex, also called a mutant. There is some subtle difference between them, but I don't remember the difference. All right. All right, that's Max again. That's another repeat winner. That's a new one, all right? New for tonight. All right. Good. Well, we got one more section to go, and we got time. We can do it. All right, so let's do the rest of the slides. So, all right, so we talk about services. Services are programs running in the background, and they're not intended to be used directly by the user. They're like DILs, but they're not DILs. They're running in the background, and they have some means of taking input, so you can request service from the services. And they typically launch before you log in, so they typically run as system with high privileges, although not always. And that's because the services are often used by Windows to get it going and by Windows to let you log in and such. So if you can make your malware into a service and make it automatically launch like all those other services, that's another good way to maintain persistence. So the SC manager is the service manager. You can create a service and start a service, and you can, here's a type of service. A shared process is the most common type. This stores the code for the service in a DIL, and then it appears in Task Manager as SVC host. So this one executable is used to load many services in batches. You'll see maybe 8 or 10 instances of SVC host.exe in Process Explorer, and each one of them will be hosting 5 or 10 services. So here's all these SVC hosts, and if you hover over one, it'll tell you what it's running. This one is running all these crazy things. Network connections and offline files and superfetch and Windows Driver Foundation. That's what SVC host is for. That's why you'll see a bunch of them. These are running all those background services that are providing features to Windows. And we played with some before. I did some of that DIL hijacking stuff. We were playing with some of these services. Anyway, so here's other types. Here's one that runs as an exe in an independent process. And there's kernel drivers, a special kind of service to load code in the kernel, of course, where it's going to run with high privileges. So the services are controlled by registry keys. You can go to Control Set Services, and then you'll find all these services here. So here's the browser service, and here it tells you this is the LAN server. Here's the path to the DIL. Here's some parameters for it. Here's the path to launch it, SVC host -K. This is the group called net services. So this name will define the ones that are all in one batch, running as part of one process. And that's why I say if you get in the registry, you can just add your malware to one of these things, and then it will add it to one of these lists. You'll have all the Windows features, and then one of these will be your malware. So all you have to do is get in the registry and add yourself to the list. All right, you can do it from the command line too with the sc command. This is the command line browser, so you can do sc query the browser service and get all the information about the browser servers, which is the same information we just saw by looking directly in the registry. And you can create services and start them and stop them and all that jazz with the sc command. Of course, you have to have sufficient privileges, which is typically you got to have administrator privileges to do very much with these services. COM is another kind of model. These things are called object linking and embedding. For these component object model things, another thing sort of like a service that runs on machines, and so you call these things these initialize functions, and then you can call COM libraries. They're addressed with these globally unique identifiers, which are 128-bit values like IP version 6 addresses. And you may remember there's this thing in Windows XP that got a lot of attention called God mode. You can go to the run box and type in this long hexadecimal thing, and then you get this panel that's basically the same thing as control panel. These numbers are the same in every Windows machine. They call them globally unique because they're not unique. This is the general rule in Windows. Everything is always named the opposite of what it is. But anyway, so class identifiers are here and interface identifiers are here. So you can refer to objects in Windows with these unique identifiers. Yeah, it's just a service packaging method. These are not equal to services though. They're another way to make shared software objects, which is why there are so many different kinds of software running on Windows machines. It really is amazing. It's the all-purpose operating system, so all these different things are running together. And of course, the point is a malware author will find the most obscure, forgotten old thing that you don't even know about and use that. And Microsoft has such a dedication to supporting old stuff, backward compatibility, that all these old things from MS-DOS and Windows 95 are still around. And often that's the way to sneak things past all your defenses. So you can have exceptions. Every operating system has this issue. You can try to do something illegal, like something you don't have permission to do. And if that happens, it triggers an exception. And the exception goes to the structured exception handler, which is a place where you can put code, if you're a developer, handling exceptions inside your application. If you're, like I mentioned when we were doing that assembly language to open a network socket, that if you were a good programmer, it would be all full of read the errors. So you would correctly handle the errors. That's what you mostly do when you're professional programmers, make sure that all the errors and exceptions are handled. So it's in this file FS register, shows where it is, and you'll have exception handling information here. It's going to push it into this location. There are segment registers in the processor, and FS is the one that points to the exception handler. So when a bad thing happens, it goes there to find addresses to code which might handle that exception. So we talked about this before. The kernel mode is in ring 0, and ring 3 is user land, and ring 1 or 2 are supported by the hardware, but they're never used by Windows. So those are the only two options. And so user mode is where everything you launch, everything from the start button, everything from command line, everything after you log in, you launch in user mode. And you aren't allowed to use any of the hardware. All you can do is call API calls, which go to the kernel and let kernel code catch the hardware. And the kernel code is all written by Microsoft, or it's written by device developers like printer drivers. And nowadays, Microsoft really strongly encourages the people who write drivers to submit it to Microsoft and let Microsoft test it for quality before you put it in. And they require that for server operating systems unless you go turn that off. So your user mode process has its own memory and such. And if a user land program crashes, then it does not crash the entire operating system. Just that one program crashes. And even if the developer didn't have a exception handler that took care of the crash, Windows will just pop up a box saying your program has stopped, click here to restart it, or please tell Microsoft about this problem, or something like that. You can't jump from user mode to the kernel. You just make a call, sysenter, syscall, or int2e. Those are instructions which will then call specific kernel functions based on these parameters, just like we've done in the assembly language parts of this course. All right, the kernel is really sloppy. I was horrified years ago when I found an IP version 6 flood attack that would kill Windows with the blue screen of death. And I showed this to people, and developers said, well, in the kernel, there's no memory control, no process. If you just use up all the memory, and then the whole machine will crash. It doesn't check to make sure memory is available before launching it. And I said, how can that be? They said, just to make it faster. There's no time to waste on that in the kernel. That's really true. So if you have an invalid instruction in the kernel, the whole OS dies with the blue screen of death. And if you your software and firewall is running kernel mode, so also your device drivers, so there's a bunch of code that Microsoft did not write running in the kernel, and when it crashes, you get the blue screen of death, and Microsoft gets blamed for that. So Microsoft keeps getting more and more picky about letting other people put code in the kernel because it's bad PR for them. Anyway, you can put malware in the kernel, like a device driver, and then, of course, that's where most rootkits go. That's the more difficult kind of malware to write, more difficult to remove, and much more powerful. It has complete direct control over the machine. All right, and then one cool thing is the native API. So this is something that only internal Microsoft developers are supposed to use, but now anybody can use it. As I'm going to demonstrate the WinDebug project later. Microsoft can't hide anything from you. You can totally see exactly what's going on with the operating system in WinDebug. So here's what you're supposed to do. If you have a user application like a browser or Microsoft Word, and you want to talk to the hardware, you have to send something to the kernel. What you're supposed to do is load kernel32.dil. And that has functions you call, and those functions will call ntdil, which will then call NTOS kernel and touch your kernel data structures and go to the hardware. This is the expected way for you to use the kernel. All right, but this is the native API. You're not supposed to call this directly. It's not even documented. It's only for Microsoft's internal use, and they put it in other things like kernel32. This is the one intended for customers, developers to use. But if you want to, of course, the native API is more powerful. It's more closer to the kernel. So if you do, and a lot of security programs that you run, like antivirus and such, actually watch calls here, which go to the hardware. But if you skip over kernel32 and call ntdil directly, calling the native API, you will skip past some security programs. And of course, that's why malware authors like to do it. So here's some native API calls: query system information, information thread, and these give you much more information than the kernel32 calls, because they're right at the lower level, letting you touch things directly instead of seeing the process data that you'd see through the user-friendly kernel32 API. And here's NT continue to return from an exception. So this can transfer execution in non-obvious ways to run something where it's not obvious that you didn't use anything simple like a call instruction to get there. You managed to redirect execution over to there in a way that's harder for someone to reverse engineer. So anyway, I got one more Kahoot, and then we'll take a break, and I'll demonstrate some of these projects. That's silly. It's like a secret Microsoft API. That's what everybody knows about. Well, everybody has this. If you do reverse engineering, it's all that. If you do hardware hacking, they have this firmware in your device, like all your Internet of Things devices, like your router and everything, and you're not supposed to mess with the firmware, but in fact, you can just suck it down, open it up, mess with it, and put it back. I've been doing it forever. It's, like anything else, there's a bunch of technology in your devices that is not user serviceable. But if you're a hacker, you can get in there and mess with it. They don't give you a manual or instructions or make it easy, but it's not like they can actually stop you from doing it. Anyway, all right, go to 7C. It's not that different than like taking apart your television and playing with it. Yeah, using the ports. Yeah, exactly. Apple used to take the numbers off the chips and stuff. They can try to make it hard, but they can't stop you if you're determined enough. People that make devices commonly assume that nobody would bother doing this ridiculous, tedious thing, but hackers are these strange people that really will spend 10,000 hours figuring out how to get in their PlayStation and make it do something strange, you know. All right, what's the user account more powerful than the administrator? Yep, that's system. That's what your machine runs as while it's booting up before you log in. Most of those processes are running as system. All right, what thing loads in ring 0 code? Well, what service loads ring 0 code? That's kernel driver. I see a comment here that if you block the ports that your smart TV is using to beacon to Amazon, the TV thinks you can't reach the internet at all. Yeah, and Irvin is real big in this now. Irvin's built himself a hardware graphical firewall, so he has a wall of LEDs that tell him what's going on in his network. And he started blocking almost all your devices, and all your software are constantly phoning home without telling you. And he's starting to block all that and see what happens. Like about 2 months ago, every Mac program I launched would take like a minute to launch. And that's because for like 2 years now, every Mac program, when you launch it, it sends, we picked it up in Wireshark when we found out about it, it sends like a hash of the program to Macintosh, to Apple, and it will not launch the program until Apple decides that's okay, it's not malware. And Apple did something like put out a new version of their operating system, so their servers are busy. So every Mac on Earth was super slow for a few days for that reason. You can't launch a program without sending a signal to Apple to get permission. And the same thing's true of Windows 8. Everyone freaked out when Windows 8 came out. Every URL you go to, it sends it to Microsoft and doesn't open until after it's checked, and Microsoft says they're testing to see if it's malicious. So instead of, so it checks to see if it's on a list of known bad sites, and then Internet Explorer won't go there. So people say they're spying on you. They all say, well, we're improving your safety by implementing cloud security, and we didn't mean to spy on you. That's just a side effect. But anyway, that's the thing, you know. It's if you tell me if your computer is a server or a client, and tell me if this window I opened, like this window right here, is coming from my machine or if the processing being done elsewhere. And the answer is everything is very complicated these days. Many different computers contributed to this. Many of them are involved. You know, it's a long, long ways from the early days of like MS-DOS, where there's no internet and I have one computer with one processor running one process at a time, and I know what it's doing. We're very far from that. Anyway, this was a kernel driver. So where's the native API? Okay, that's ntdil, which we're going to play with. All right, and which item is used when you do a divide by 0? Okay, that's the exception handler. Structured exception handler is what it stands for. All right, that's a 2-time winner and a 3-time winner. And I guess the first time that person's won today. All right, good. Anyway, there we are. So I'll stop this recording.